Good morning. Good morning. Namaskar. Good morning, everybody. This is Engineer Suraj Singh speaking from Bharat, India on this day, December बोल रहा हूँ. This time at the morning 3:50 a.m. 3:50 सुबह के. Title of talk is Civil Field Engineering, Concrete, Quality, AnnexSL, Contract forms like Red, Silver, White, Safety, Health, Environment, Designs and Construction, Methods, Contracts, likewise, Disputes, Organizations, Communication, Coordination, Why, Quality of Materials. We have to consider every time that is issue here, and these are certain certificates which I always try to reflect just for information for you people. Another one, and all of that is formal body, official body, and here is quality document that is important for everybody, because I always start with quality, because quality is very important. And if you are pleased to communicate with me regarding something pertinent this video, if you want to comment something, if you want to write something, or if you want to seek certain information, you have seen that it is in English as well as in Hindi. There should be no problem for someone to understand that. You should not feel any problem. It is in Hindi and English both, but purpose of this is to share with you my email that I usually use, and that is here SURAJ Suraj _ ENGINEER engineer at yahoo.co.uk. You can write to me. I will be happy to respond to you on this email. Again I say, this is Suraj _ engineer at yahoo. About profession, and of course quality in profession, because quality has been ignored. It should not be. क्वालिटी को मजाक में लिया जा चुका है. Signals are fully down, video 0, audio 0, really, and only no FPS means sometimes I feel threatened by these signals, because I know my voice or making money, charging fees. It happens with everybody, I'm sure. You may also be feeling same type of problem. आपको भी वही दिक्कतें आती होंगी जो हमें आती हैं. सिग्नल्स नहीं मिलने की वजह से, कम मिलने की वजह से, कंटिन्यूस नहीं मिलने की वजह से. ब्रेक होना सिग्नल्स का कोई बहुत नई बात नहीं है, फिर ब्रेक हो रहे हैं. क्या करें, मजबूरी है. पता कंज्यूमर के साथ, यूज़र के साथ एयरटेल वाले कर रहे हैं, और भी कर रहे होंगे, मैं नहीं जानता. मैं अभी तक एयरटेल यूज़ कर रहा हूँ. पहले टाटा यूज़ करता था, टाटा बंद हो गया तो अब एयरटेल चल रहा है. शुरू में भी एयरटेल करता था, बंद कर दिया था. लेकिन ये लोग सुधरने वाले नहीं हैं. ये लोग सुधर नहीं सकते. पैसे इनको टाइम में चाहिए, सर्विस दे नहीं सकते, देते हैं तो रोते हैं. आप इनको कोई कंप्लेंट कीजिए, ऐसे जवाब देंगे कि हमने ठीक कर दिया और कुछ किया नहीं होगा. आप मेरी बात को माने या ना माने, लेकिन सच्चाई बोलने में पीछे नहीं हटना चाहिए. ये लोग सिर्फ मनी मेकर्स हैं, इससे अलावा इनका कोई लेना देना नहीं है। ये सर्टिफिकेट बंद कर रहा हूँ और ये भी। नाउ इट इज़ अबाउट क्वालिटी, about communication and coordination, which I usually talk of, because for me communication and coordination is very significant. मेरे लिए ये बहुत महत्वपूर्ण है कि कम्युनिकेशन, संचार या कोऑर्डिनेशन अच्छी प्रकार से होनी चाहिए। We should be very concerned about communication and coordination issues everywhere and particularly in our professional domain. I did not know what is coordination before when I was young. I mean, real meaning of coordination was not understood, though we used to do that. Nobody taught us about that. In our education system, it was not included, but it is not necessary that it should be included in your education system. That's also true, because education system is well measured. Syllabus and program of education are well settled. You cannot expand them, you cannot shorten them, because you have to learn basics of education first, basic subjects. Even in engineering, you do not become engineer after passing your examination. Do we call this person as an engineer? Of course, by education, by academics, one becomes engineer, but it is dependence engineering. You have to learn actually for a couple of years. Prior to that, you become an engineer. In fact, you have confidence. To earn that confidence, you have to work in field. आपको अभियंता तो बन गए, आपने सर्टिफिकेट तो ले लिया डिग्री का या डिप्लोमा का, लेकिन आपने काम नहीं किया फील्ड में। ठीक है, आप इंजीनियर हैं, मानते हैं, आप बहुत अच्छे पढ़ के आए, वेरी वेल एजुकेटेड पर्सन, पर आप क्या पढ़ के आए आप भी जानते हैं और मैं भी जानता हूँ। आप पढ़ के आए सब्जेक्ट्स, जो भी सब्जेक्ट्स रहे हो 30-35 होते हैं इंजीनियरिंग में। पहले बहुत होते थे, अब कुछ कम भी हो गए होंगे, कुछ बड़े भी होंगे, सिस्टम्स भी आ गए हैं, क्वालिटी भी आई होगी, सेफ्टी भी आई होगी। जो भी आया अच्छा आया। I cannot say no. Life moves on, and we have to learn on and on. If you stop learning, you cannot do anything. And engineering is such a field like medical science and like other major professions where continuous learning remains very important, becomes very important. It's becoming actually. If you don't learn, if you don't teach yourself during your work, I cannot say why. What is the answer of that? If I do not learn, I do not refine myself. Because, when we say practice of profession, what does it mean? Profession is practice. Profession is not silent. For example, if I have 3 degrees, for example, I have BE, ME, PhD, let us say. I'm saying I don't have, I'm just giving an example. Your degrees are not important. Important is if you apply them, or if you have opportunity to apply them, or if you have such an assignment that you can apply them, you can use them, then it's better, it's best. Because you know input of that, you know output of that, you go in depth of that, you go into sections of that. All sections you go, you are exposed to that. Exposure is very, very, you can say, important in engineering. You may be a design engineer by education. You say, I'm a structural design engineer, or I'm a structural mechanical design engineer. You can be. That is theory. And theory is first requirement, I understand. If you don't know theory, we cannot do practical. That's also true. But that theory is limited to only design work or only to basics of engineering. But engineering is always advanced in field. There's a difference. Engineering applications are done in field much before then, before these arrive to university or institutions, or you consider academics. There can be gap of couple of years. It is way means from field, from profession, real professional environment, it goes to academics. Means by that time academic understands it, another technology comes and that becomes obsolete. You can say that whatever we learn in our institutions all over the world, that is not exactly what is current. That is not current, that is the old one. We study old one except theory, because theory is different. For example, we have subject theory of structure, we have designs of structure. These are very explanatory, very expansive, voluminous subjects. We cannot study everything during engineering education. Limited subjects we have to cover, otherwise we cannot pass. And passing is very important. All subjects cannot be covered in a couple of years, but you can say it is threshold that we know. Means we understand that much, we can apply in field, and when we apply in field, actual education it starts from there. And for that, basic education is required, and that basic education is first degree and more degrees. If you want to go into field of, you can say, non-practicality, you can do higher education, go to master's degree or doctor's degree, which are not going to be very productive as far as engineering field is concerned. Yes, you may become a professor, you may become a teacher, or you may become a researcher, but my boundary is not that. Enough research has been done in field of engineering, particularly civil engineering, other engineering, and it causes always a problem. For example, you can take IT engineering now. Every other day you find update. Previous of software could not be used properly and you get update. What's benefit of that? Sometimes it's so complicated that your old version is out of use. You cannot use that and you have to find new version. Why so much? So many people even do not know today about, for example, this is Lotus 123 spreadsheet, or you can say Excel spreadsheet. There's so much in that even I think that software company doesn't know what is actually this. Because it's so much, we have not used that much, you get update. What happens even sometimes, there are so many formulas, so many commands in this software which are not used. And another one comes and previously is deleted. It happens. This means without using thoroughly some software, we have to update it and get another one. That's what I'm saying. This is not right. Something should be available for long term. But in civil engineering, this does not apply. Because civil engineering product is for long term. For long term, what we say. That's why in our case, in civil engineering, you can say communication and coordination are very significant topics, very significant subject, I should say subject. Because these are interrelated. संचार और तालमेल या संतुलन सिविल अभियांत्रिकी में, नागरिक अभियांत्रिकी कह सकते हैं इसको आप, नागरिक अभियांत्रिकी में इतने इम्पोर्टेंट हैं, इतने महत्वपूर्ण हैं जिसकी आप कल्पना भी नहीं कर सकते. कारण टेक्निकल वर्क. जितना टेक्निकल वर्क, नेचुरल टेक्नोलॉजी, नेचुरल मटेरियल्स हम लोग सिविल में यूज़ करते हैं, जिसको हम इंजीनियरिंग नहीं समझते, जबकि है. मिट्टी का यूज़ हम करते हैं, गारा का, पानी का, और आप कह सकते हैं रोड़ी पत्थर, हवा, ये सब हम इंजीनियरिंग में यूज़ करते हैं. सिविल इंजीनियरिंग इज़ फुल ऑफ नेचुरल मटेरियल्स. You can say water, soil, stone, air, whatever materials are available in nature, we perfectly use them in civil engineering, construction and designs. And why don't we understand? What is that? What is this? We have to deal with all those materials, and it is good that much literature is available about these materials, but that is not extensive and exhaustive. We design specifications, we design systems, we design structures, and we design so much. And some people don't want to call them design, they want to call specifications, they want to call something else. No problem. Specification is also a part of design. Contract too is a part of design. Contract conditions too are part of designs. These are not ordinary designs, these are non-structural designs. These designs move projects. If you don't have specifications, if you don't have contracts, we cannot move project. That is also true. And moving project is very significant, very, you can say, paramount important. We can say that technical activity cannot be done by talks. Technical activities cannot be done by signatures. Technical activity is done successfully and it is confirmed by real work. This means if I learn something in my university, it must be done practically. And that doing practically is quite different than what I learned in field. Therefore, quality can be defined is completely different. What was told, what was learned is not same as I do. Because when we do something, we are exposed to reality of work, reality of organization, reality of actual work. And those may be linked to professional engineering or they may not be linked to professional engineering. Unfortunately, writing skill is not developed in our education. Coordination is not known. What is coordination? Does not coordinate. I'm not criticizing anyone. No need. When you work in field, you shall know what is coordination. If you do not know coordination, if you do not conduct anything about communication, then you won't be a successful engineer. You cannot stay anywhere. आपको कहीं काम नहीं करना पड़ेगा क्योंकि आप जानते नहीं काम करना. आप संचार का मतलब नहीं जानते, आप कोऑर्डिनेशन नहीं जानते, तालमेल नहीं जानते. और इंजीनियरिंग तो एक फुल टैंक है, फुल समुद्र है इन चीज़ों का, जिसमें हर स्टेप पे कोऑर्डिनेशन जरूरी है, आवश्यक है. हर स्टेप पे संचार माध्यम आवश्यक है. संचार माध्यम का मतलब इंफॉर्मेशन से है, सूचना से है. और सूचना समय पे मिलना, आवश्यक समय पे मिलना अत्यंत आवश्यक है. क्योंकि अगर सूचना आपको नहीं मिली, आपको किसी भी चीज़ के बारे में इंफॉर्मेशन नहीं मिली, जैसे ड्राइंग्स के थ्रू मिले, स्पेसिफिकेशन के थ्रू मिले या किसी और स्टेटमेंट के थ्रू मिले, तभी तो आप काम करेंगे, नहीं तो कैसे करेंगे. इट्स वेरी बिग इशू दैट quality, if you want to achieve, if you want to confirm, if you want to claim that I got quality, in that case we have to understand all these connections, all these interactions, and we call them by name: communication and coordination. It's not news communication, no. I'm not talking of mass communication because that is different. I'm talking of work communication. Work communication is always very, very specific, and in engineering it is very, very, very specific. You want to do something, you have experience, but you don't have confirmed information. What you are going to do, how you are going to do, who shall tell you? There is no one to tell you because you are a responsible position person. You are a responsible person. They would say, you do it, you are an engineer. I was in Libya, I was in Iraq, and usually when information was not available, or I used to complain something about some non-information to our those Arabic people, you know what he used to say? You are engineer, decide. Well, sometimes I was surprised because I didn't involve myself in that kind of working environment in our country. Nobody will say you do yourself, you know it. Because here documentary records are available. We have immense volumes of specifications, maybe standard one. Likewise, we have many other inputs that we get here, but that is only theoretical, not practical, because those who were involved in them who had never field experiences. And that is no use if you have some coefficients in any item. Oh, this is coefficient, use this. But that coefficient was never practiced. Means culture doesn't exist, coefficients exist. आपके पास कल्चर नहीं है, आपका जो भी कोफिशिएंट एक थ्योरेटिकल है, एक इमेजिनरी है, and that doesn't work actually. So we have to study in field first. Field doesn't mean ground, field doesn't mean site, field means profession. Scope of work in profession, whatever is our ambition, whatever is, you can say, diversity in profession, civil engineering profession or interactive engineering profession with other like mechanical engineering, electrical engineering, IT engineering or whatever else. We can say that I'm talking of that field. I'm not talking of field in ground or site. Some people are little difficult in understanding what is meaning of field. Field means civil engineering field, I should say, rather than site or something. Site is site, that's work. That is, project. I'm not talking of that. Project exists everywhere. If I say project, I mean to say project means field plus design plus bidding plus construction, and that's equal to delivered project. That is engineering profession. My field includes all these. So just take it differently. I'm not saying site engineering only, though I have enough experience for working on site. I'm not having very much experience in designs, that is true. But it doesn't mean I cannot do designs. If I know method of design, I understand procedure of design, I have conception how shall this item perform, how shall this structure perform. Design is not a big issue if you know software, or even if you don't know software, we can design using first principle of designs, and first principle is always very useful because that is basic element in designs. If you do not understand concept, if you do not understand basics, fundamentals of design, there is no meaning of design. You have to talk to yourself, and you have to talk to your proposal, and you have to talk to everyone, every contemplation that you have. आप जो भी सोचते हैं, जो भी समझते हैं, जो भी विचार आपके माइंड में आते हैं, उसके बारे में आपको सोचना पड़ेगा. And that is where, it varies. It's not simple profession to just make money or some method has been fixed and you have to follow that. Engineering is a conception. Engineering means you have to produce something. Every design is a kind of research, it's called operational research. Or you may say a new design is never same as an old design. All designs are not same. You have a building, you design another time that building, you design third time that building, you shall find you forgot what you designed last one. You cannot remember that. आपको याद नहीं रह सकता कि आपने उस डिज़ाइन में क्या किया था. एक आइडिया तो जरूर होगा कि मैंने ऐसे किया था, लेकिन आप उससे एग्जैक्ट वही नहीं शेप दे सकते, वही डिटेल दे सकते जो आप नए में देंगे, बिकॉज ऑफ योर एक्सपीरियंस, योर नॉलेज, एंड मे बी हैव मोर इन्फॉर्मेशन दैट हैव कम इन. Information have come in, and that's how it makes impact on designs. You have different specifications, you have different codes, and codes are of course very important as far as designs are concerned, as far as actions are concerned, as far as materials are concerned, because codes are available. This is a very descriptive, in fact, and I don't think that exclusively dependence on codes we can move forward. Of course, codes are considered references, माध्यम है ये authority के, we have to be careful about that, but codes are written by those who might not have that exposure in field. Generally, as somebody rightly said, and people usually think that engineering codes are produced by those people who are either professors or used to be professors or used to be industrialists or who never had any exposure in field of engineering or field of, you can say, real engineering, I should say, rather than engineering, because for them marketing is also engineering and for them conference is also engineering. So I don't consider all this engineering because there is no meaning of that until you have some goods delivered. So codes are kind of, you can see, is a direction only. Doesn't mean you can have your own codes because you are an engineer and you can think on that and you work and you have experience of that. That's what my quality concept is quite different. Means it's not what people think quality is. According to people, it is quality testing. It's not quality in fact. And I'm not talking of quality testing, I'm saying quality in construction, means construction system or system of construction, you can say. Just like a system of framing, system of designing, various systems in design. That's a construction is a super specialization, you can say. Construction is not just beam and columns. Construction is not just excavation and concreting. Construction means you are going to deliver that structure which has been designed. You have going to that structure which is never clear about its foundations. Though we assume so many factors, we assume so many design parameters, but are those real? Nothing can be guaranteed. And moreover, what is below soil? We can go only up to a few meters for testing of soil. We cannot go up to center of earth. So what I am saying is, it is sometimes unknown. We can design to some extent only. We can work to some extent only, and we depend on properties of materials. And if those material properties, maybe these are all right, and we can produce good, and we can apply our efforts for best considered quality. It doesn't apply same way in manufacturing because manufacturing is controlled, but construction also should be controlled, and it is controlled, but that control is not proper as I understand. It's quality control rather than quality organization. As we say, quality system is quite different. They also know, and that's why quality systems exist. We may call it total quality system. We can call it total quality system, but does it work? If we do not get product quality, we cannot justify that system operates. If product is not quality one, for example, there is an engineer, if you have doubt in that engineer, you shall certainly ask from where did he qualify? And rather than blaming or thinking that engineer is bad, it did not study well, or just study for passing and not learning. There's a difference in passing examination and learning. Passing examination is only momentary, you have to appear in paper and pass, but learning is lifelong. What did you learn in university, that is different. And if somebody questions someone from where did you pass, means in a negative way, then you can say you are not a good person because that university is bad. That body from where you pass, that's not good one, but it doesn't happen. It's not fault of body, it's fault of that individual who did not study well, and I am also one of those, you can say. And maybe I today realize I could do better. But at that time, you were young, you did not, maybe I didn't know what I was studying sometimes, or how shall it be useful. We studied so many subjects, and for example, electrical engineering, elements of electrical engineering, and of course thermodynamics example is like that. Various subjects which have no relation to our profession, we study. But when you realize in field, yes, there is some relation. We cannot simply say no relation. हम नहीं कह सकते हमारा कोई ताल्लुक नहीं है इससे, हमारा कोई रिश्ता नहीं है इस सब्जेक्ट से. फील्ड में रिश्ते आ जाते हैं, फील्ड में रिक्वायरमेंट आ जाती है. In field we have to think of, if I construct a building or I construct something else, then I have to deal with other professions like electrical engineering, mechanical engineering, or you can say nowadays security engineering, controls engineering, Many subjects are there, many disciplines are there that got nothing to do with my profession, but nowadays this is not, you cannot say it's my profession or your profession. We have to say engineering profession. Of course, your own is specialized one, you are master or you are good for that, but other professional coordination is required. And that's why I use term coordination. Coordination applies everywhere. You have to understand about others. Others means not in person but in work. I have to understand something about electrical engineering, something you can say, not elements even, something work wise. Means we should have some work understanding about electrical, about mechanical, or about machines, or you can say about heavy equipment, and also you can say whatever you are going to do, we have to understand that. And that's why I say interaction with others is important, and therefore quality cannot be isolated. You cannot say I am independent, my profession is independent, because your profession is not independent. Others' profession is also not independent. We are dependent on each other because of various reasons, because of technology, because of material, and no technology can work independently. And that's where coordination becomes very important. इसलिए कोऑर्डिनेशन हावी हो जाती है, और कोऑर्डिनेशन हावी होने का मतलब है संचार माध्यम हावी होना, कम्युनिकेशन हावी होना। और अगर हम कम्युनिकेशन को भूल जाते हैं, कम्युनिकेशन की वैल्यू नहीं देते हैं, जैसा आजकल हो रहा है, लोग समझते नहीं हैं कम्युनिकेशन क्या होती है। यहाँ तक कि आप न्यूज़ माध्यम भी देख लीजिए, न्यूज़ चैनल देख लीजिए, उनको कम्युनिकेशन का मतलब नहीं पता। वो समझते बस इन्फॉर्मेशन दे दी, हो गया काम। कम्युनिकेशन का मतलब बहुत होता है, कोऑर्डिनेशन का मतलब बहुत अधिक होता है। शायद मैं समझता हूँ कि इंजीनियरिंग से भी ज़्यादा होता है। अगर आप सही कम्युनिकेट नहीं कर पा रहे, सही कोऑर्डिनेट नहीं कर पा रहे, तो आप कब कर ही नहीं सकते। सच बात है। इफ़ यू आर नॉट एबल टू कम्युनिकेट प्रॉपरली, इफ़ यू आर नॉट एबल टू कॉम्प्रिहेंड complete communication and coordination, it is never possible that you shall be able to do right work. You shall miss something. And that is where I find that young generation of today, current young generation, because of many reasons, they have lost foundation of communication and coordination. They neither understand what is good communication, and they also do not understand what is coordination. In construction, if we have to achieve quality, first we have to achieve quality of communication, we have to achieve quality of coordination, and we have to understand this very well. Because if you want information, if you want to get information, it is only communication that can give you information. And when you use communication, certainly coordination comes into play, and that coordination is technical one. That coordination cannot be understood by everybody. I have seen some engineers are very good in writing, and some are very, you can say, some are normal in writing, and some even don't like writing. I know majority of engineers do not want to write much. They want to talk much, and they want to instruct. Okay, instruction is your part, but just talking is not enough. Engineering does not move because of talking. Engineering moves because of written instructions. Written instructions and right instructions. Written instruction is very important, and writing, or you can say written instruction is very important, and you can say right instruction. And right instruction cannot be given just by because you write something. It is to be well coordinated. It should be very well coordinated. It may be production work, or it may be construction work, or you can say even if it is services, design services, or teaching services. Even a professor has to be very careful while teaching students, because every movement of professors is very much significant in world of engineering. Every professor is very significant to teach one's student. If professor cannot train a student, what is function of professor then? Well, I'm just giving reference only. I'm not saying professor is good or bad. Professor is very top profession. Though it's not profession, but we let us say honor is a rather profession. Honor is much important. So profession is very significant. If you are an honorable professor or a teacher, you are intellectual, you are intellectual and you produce intellectuals. There's a difference. Professor is a manufacturer of engineer, manufacturer of doctor. If I am an engineer, I am a product of some, I can say, a group of professors who taught me during my career, during my education career. They taught me. So they are all my machines, they are all my manufacturers. You can say that in understanding. And I am an individual and they were also individuals. Individuality is significant. It's a rock. It's a soft rock or hard rock or fractured rock. I cannot say it's limestone rock or volcanic rock, igneous, or it's metamorphic rock, or it's just dust, or it's a dune. I do not know what sort of person one is. That person knows. What sort of power that person is, that person knows. I know about myself, you know about yourself. How much you can do, only you know. Others cannot know, but others know when they deal with you in profession. How do you run your project? That reflects your capacity. How do you reflect your capacity in engineering world? Everybody can know. In that there's nothing secret, and that is performance. If performance you have, you can perform. People like you. People like you if you give quality, and quality is required in every field. क्वालिटी इज रिक्वायर्ड एवरीवेयर. ऐसी कोई जगह नहीं, ऐसा कोई काम नहीं जहाँ गुणवत्ता की आवश्यकता ना हो. जीवन के हर खेल में, जीवन के हर काम में क्वालिटी आवश्यक है. वो अलग बात है, हम नहीं समझ सकते उसको या नहीं जान सकते, लेकिन आप कुछ खाना भी बनाते हैं घर में तो उसमें भी क्वालिटी होती है. आप डिफाइन नहीं कर सकते उसको, लेकिन होती है. प्रोसीजर होता है, मेथड होता है, रेशो प्रोपोर्शन होता है, और उसका कुकिंग का तरीका होता है. क्वालिटी हुई ना. लाइफ ज़्यादा आज के टाइम में इंजीनियरिंग से लिंक हो चुकी है, ये भी पक्की बात है. वो अलग बात है कि हम नहीं समझते, लेकिन है. ऐसा कोई प्रोडक्ट नहीं हो सकता जो इंजीनियरिंग का ना हो. Our life is full of engineering activities. There is nothing that we use today, no product that we use today, which has got no relation to engineering or medical. Though I'm not talking of medical, but I just bring it into my reference because medical and engineering are related. If health is not good, how can I work? That is first point. Health is important for mind and for body. Same way we should have good health in engineering products. If my product, say structure, has been produced but it is not healthy, it's not safe, how can this product survive? How can I guarantee that product? That is bad health. That is unsafe. I cannot guarantee that. But even then, people little bother. We do not understand what is consequence of bad quality. We do not understand what is good benefit of good quality. Quality must be well understood by every engineer, and not only every engineer, by everyone. to some extent, you can say. You cannot say full extent, but to some extent. We can understand impacts only when accident happens. Oh, this structure collapsed, this building collapsed, this happened. And not only in our country, it happens everywhere else. It can happen everywhere during construction, during use of that product, that structure. It can happen, and it's happened many places in the world. We are not separate, and quality system stands, it works as well as sometimes it fails also due to ignorance and due to non-care attitude of individuals. And therefore I can say that life has a relation to professions not because of money but because of use. Maybe engineer does not earn that much as others do, it is also true, because abundance of engineers are available. But how many percent of them are engineers? That is to be scrutinized, that is to be researched. Engineer means should be independent, and how many persons are independent? It comes into a question domain. Therefore, we have to be little careful. Means engineering is based on thoughts, is based on your capacity to think, it's based on your capacity to convert your knowledge into practicality. It is quality. Safety is also something that we ignore many times. We ignore many times, and accidents happen, mishappen, you can say. It always happens. I have to talk of some very important elements in our engineering. I have to talk about contracts, and I have to talk about, you can say, concrete also. I talk to you about general conditions of contract. I talk to you about FIDIC, and still I am busy. Sometime I take that portion, sometime I take this portion. It depends upon what is important. In engineering, particularly in civil engineering, we all know that concrete is a prime element, prime material. Without concrete material, generally you can say we cannot survive. Concrete has become that part of our life that if concrete doesn't exist, our construction got no meaning. It may be RCC construction, or it may be structural steel, or it may be pre-stressed concrete, or whatever we can say. Concrete is required in all works. I discussed about it long back, and yesterday also I tried to some pages. Concrete, you can say, is very much part of contract, and very smart part, very active part in every contract, in every project. And you can say a major part of every work, every project is concrete, because it is body of, it is structure, concrete structure we can say. And if concrete fails, if your structure fails, every other parter, every other content, every other article, every other material that is put on structure goes away. If there is a failure in structure, whatever you have put on that in form of finishes, in form of flooring, in form of, you can say, walling, all those go away. From safety point of view, from quality point of view, from contracts point of view, or you can say from whatever else point of view that can be considered, concrete is high profile, highest profile material. Though it is done on site, It is done after a lot of work, research. Only work, research that is done in concrete designs. We design a lot, then we have to try to find how best we can carry out concrete work. So we can say that concrete is a dominant item. It dominates every other item. For plastering, we don't have to think too much. We don't have to design too much. Same way for painting and for other finishes, even for block work or brickwork, we don't have to think a lot on designs. But on concrete element in every structure, and sometimes even concrete element is only structure and only project. It's long-term use product. It cannot be said, I put this concrete, I use this concrete for 1 year or 6 months. Concrete is used for too long a duration. We have no answer today. And that is a result of, if we understand concrete very well, which we have failed so far, particularly in our country, people are not very serious. We know in our country, Bharat, India, we have no culture of being serious about work. We have no culture of owning responsibility in world of engineering. Our youth today, they are not interested in civil engineering. That's also a fact. हमारे युवा सिविल इंजीनियरिंग की तरफ नहीं जा रहे. साफ है कारण कि शायद उनको इतना रिटर्न नहीं मिलता सिविल इंजीनियरिंग में. ये कारण हो सकता है. यहाँ सवाल रिटर्न का तो है, लेकिन आप क्या रिटर्न कर रहे हैं वो भी है. आप जाते हैं मैनेजमेंट में, मान लीजिए, क्या करेंगे वहाँ? सोचिए. आपने इंजीनियरिंग की पढ़ाई की, यू पास्ड इंजीनियरिंग, you did lot of work for 5 years post schooling, then you gave it up. Oh, I want to join management or I want to join administration. What is there in engineering? You can say that. What is there in engineering? You are saying because maybe you are not going to get that salary as you expected in other fields. I think that is only a criteria. People give up engineering and join management, or they join something else. Well, it's up to you, but I can only say that you are not serious. If engineering does not exist, management does not exist, remember. Engineering is a platform where all other platforms can stand. Don't consider engineering in relation to how much you earn. Engineering doesn't mean earning. Engineering means giving you a platform on which you can earn. So you can say it is something different. It's like worship. I consider engineering as worship. Engineering is a worship because you may say worship or you may say workship. People usually say workmanship, or people you say, I don't like to say workmanship because I don't like to include man or woman in my talk. Work is important. Worship and workship. Because you produce something, you deliver something that may live for many couple of decades. You cannot say, I have to change it after 2 years. I have to change this building after 5 years. We cannot say that. We have to use that structure for coming many, many decades. Decades, I am saying, not single years. And we have seen buildings, of course, those built very well in past and these days too. But majority of construction still today raises question marks, raises our eyebrows what we are doing. हम क्या कर रहे हैं, कैसा स्ट्रक्चर बना रहे हैं, कैसा बना रहे हैं आप। ना कोई पूछने वाला है, ना कोई बताने वाला है। हालत यह है कि किसी को कुछ पता नहीं होता, उल्टे सीधे काम कर लेते हैं और मकान बन जाता है और वो समझते हैं हमने बहुत अच्छा मकान बना लिया। मकान का बनाना अच्छा फिनिशेस पे डिपेंड नहीं करता, डिपेंड करता है ढांचे पे, स्ट्रक्चर पे। आपने कितना अच्छा स्ट्रक्चर बनाया। यहाँ तो लोग समझते ही नहीं है, कुछ भी कहीं भी खड़ा कर देते हैं, कॉलम कहीं लगा दो कॉलम, ऐसा होता है। वो नहीं जानते लोड क्या होता है, कैसे डिस्ट्रीब्यूट होता है, किस तरह से हम लोग कैलकुलेट करते हैं, क्या क्या उसके अंदर सोच लगाते हैं। ये एक आम व्यक्ति नहीं जानता। और ना कि यहीं ऐसी प्रॉब्लम है, पूरे विश्व में ऐसी प्रॉब्लम है जहाँ एक्सेस नहीं है इंजीनियरिंग की। यहाँ लोग समझते नहीं हैं कि इंजीनियरिंग क्या होती है। उनको फिजिकल वर्क ही इंजीनियरिंग दिखता है, उसके पीछे क्या सोच है, क्या कंसिडरेशन है, ये सब वो लोग नहीं जानते। और उनका भी फॉल्ट नहीं है इसमें, उनका फॉल्ट बिल्कुल नहीं है, क्योंकि उनको तो मकान बनाना है, उनको तो स्ट्रक्चर बनाना है। इसीलिए क्वालिटी एक बहुत इम्पोर्टेंट बन जाती है। क्वालिटी इज़ टू, you can say, too significant in such case, important one. If we don't understand quality, I think we cannot understand anything. And that's why I bring into my consideration question of, you can say, question of concrete, because concrete is prime element, and even if we want, we cannot discard it. Even if I say I don't want to talk of concrete, I can say that, but that is not solution. Concrete is concrete, and therefore I just want to share with you, as I shared before also, why I consider this. And this is not my document, this is not my print, this is another publication from another state. And I have this copy, that's why I'm just referring it to. I don't say that you use this. Maybe you have your own, but only for contents. I try to project it because it's better if you understand that. In this, let's say, means it's a general part, and this is here in this. I will only give some brief. I'm not going to take at length. I have to do contracting. I have to do contract arbitration. You can say we have many issues we have to discuss. We have to discuss what is contract and what is arbitration, and why there is arbitration, or why there are disputes, what is the reason for that, where there are lapses on contracts, why there are lapses, why contracts are not clear. Because contract means agreement, and why there is error in agreement, why don't we understand what is the fact and what is not fact. Contract we generally don't consider our subject, but I think contract is much more subject of engineering than some of the blinds, some of the field. If no good contract means no good execution, no good work, no good design. So contracts are part of life, so it may not be taught well in our ordinary education, or it may be taught well, but we did not care of that, because it's very boring. There's no mathematics in that. It's the fact that in just like mathematics, that's I understand. Mathematics or formula, physics or chemistry, likewise, we are full of this use of formula. We just apply formula and get answer. That's what we think is engineering design. But I think contract and contract, how to operate contract, how to do contract, these are well related in construction engineering at least. There is a contract, but contract doesn't mean contract only. It means all supporting documents, all structured documents, we can say. In contract there are so many documents, as that's why I take this in title, Red, Silver, White, and of course engineers and concrete, what's quality and what's design, what's construction, what's method, what's sector disputes, all that. This is all one. These are not varying subjects, varying topics. They're all same, all one time, and this apply somewhere, and somewhere. Maybe sometimes we don't know it's applied, but it applies. From time to time, procedure is same. I say same thing, but variation exists in application of various topics, various subjects. मेरा कहने का मतलब ये है कि हमको खाली कॉन्टैक्ट का मतलब तो हम नहीं समझे हैं, ना समझ सकते हैं, क्योंकि हम लोग इस पर ध्यान नहीं देते, लेकिन वर्क तो हम करते हैं। वो कैसा सही है कैसा गलत है हम भी शायद नहीं जानते कई बार, क्योंकि एक धक्का होता है, ज़बरदस्ती भीड़ होती है कि हमको ये प्रोजेक्ट पूरा करना है, किसी भी तरह से करना है, और उस पूरा करने में हम क्वालिटी भूल जाते हैं, सब सिस्टम भूल जाते हैं, ना अच्छी तरह प्लान कर पाते हैं, ना कुछ कर पाते हैं। ऐसा होता है। आप शायद मेरी भाषा को ना समझें, मैं नहीं जानता, लेकिन होना तो यही चाहिए कि हम थोड़े स्मार्ट बने, भाषा को ना जाके आशा पे जाएं। आशा हम क्या रखते हैं अपने काम से, हम कितना अच्छा काम कर सकते हैं। हम इसलिए नहीं अच्छा काम करते कि हमको अप्रिसिएशन लेनी है किसी की, हमें कोई क्या अप्रिसिएशन देगा, हमें चाहिए भी नहीं, लेकिन हम तो अप्रिसिएशन दे सकते हैं किसी को कि हमारे काम को ध्यान किया, हमारे काम की वैल्यू दी किसी ने, बेशक वो ना कहे, इसलिए हम तो समझते हैं। कंक्रीट एक सॉलिड मटेरियल है, इसलिए मैं बताना चाहता हूँ concrete is very important material, very significant material, solid one, and this is naturally produced material, and this is means I naturally produce in a say that we just mix it, that's all, nothing else. We just design and mix. We do not produce ingredients of concrete. These are all available somewhere, we just collect them, gather them at a point in certain measurement. That depends on how you design concrete material. Concrete is not ingredient, concrete is solid material, hard concrete we call it, hardened concrete we call it. And that concrete is very special material, of course. It has been old, but still we do not know exactly its conduct, thorough conduct, from one point to other point, one place to other place. And of course it is very smart, because it has varying constituents, different ingredients in this. So we generally use this concrete word also in our life, not related to concrete material, but concrete state. We say this work is concrete. Did you do any concrete work? We can say it doesn't mean concrete material. It means that it is solid work and reliable work. Vishwasaniya काम, concrete is actually Vishwasaniya material. It's a material on which you can rely upon. It's not an ordinary material, in fact. It's more important than gold, you can say, because gold can't be used in the arts in that way, but concrete is more than gold, because it's going to be used for a couple of decades. It gives you something, you can say, you get asset. You may say concrete can make your assets, it can make structures, it can make roads, it can make wherever, something that works for you forever. You cannot underestimate it. Yes, okay, I don't work in concrete, but concrete works for me. So what it says in the scope of this specification, and that is, it includes requirements of concrete work. And where it is applied for, it says, it defines as it's pipelines and roadworks, runways, structures means all structures, and water retaining structures. It is the foundations and basis of structures and equipment and many more. This is, scope of this material or section, you can say. It is general, and we have to be very smart to get knowledge of everything. In this part, issue of this part includes relevant standards, definitions, abbreviations, and requirements for testing, facilities, rejected materials, and record keeping. This is only, what it contains. And in this we say we have aggregates. Aggregates, what is aggregate? हिंदी में कहते हैं रोड़ी या रेता या बदरपुर कहते हैं हम दिल्ली में, पिट सैंड कह सकते हैं आप उसको। एग्रीगेट का मतलब है जो भी कंक्रीट में जाना है, सॉलिड नेचुरल मटेरियल। और उसके बाद सीमेंटियस मटेरियल, सीमेंटिशियस मटेरियल। सीमेंटियस का मतलब जिसने इन सब इंग्रेडिएंट्स को जोड़ना है आपस में, शक्ति लानी है उसमें। वी हैव टू ऐड these in certain proportion, cement to these ingredients, or aggregates, and of course we have to use water, include water for purpose of mixing and for purpose of strengthening. Then we have many other chemicals as well that we call them in admixtures. It can be different type. There can be different admixtures, different chemicals, construction chemicals used to vary certain properties of concrete. And we will see later on there are what type of admixtures there are, certain percentages use them. In addition to cementitious materials, and these admixtures are very important to vary to plasticize concrete or to keep on hanging from being set. Likewise, it depends on what chemical we are going to use at admixture. Then we have the property requirements, and property means concrete property. What properties we want to achieve? How much compressive strength we want to achieve? What total tensile strength should have, or shear resistance it should have. That property we have to learn, and of course deflection, distortion, distress. No structure remains same forever. It keeps on changing. Maybe it is not that fast. It's ordinary change, but it changes. Same way we say concrete plants, batching plants, central mixing plant, these days. It's nothing new. It has been there long back. I saw these plants first time in Iraq when I entered 1981 mid. Same way transportation and placing of concrete. What is best way of transportation, and then what is best way of placing that received concrete to work. So this is a combined one, that you are sick and or your people are sick and you want a treatment. It's like that. Concrete is a treatment, you can say. It's a treatment to solve problems. Because the total you can say conduct of concrete, total performance of concrete is still a secret. We can't say that we know everything about that. It is still a secret. And this secret has to be well known. That secret has to be well known, and we know it. It is likewise, you can say, as I said, transportation, placing of concrete. What is best way of its transport from mixer? Mixer, it may be batching plant mixer or it can be site mixer, to location where it's to be laid or placed. So that transportation is a very important, powerful mechanism or activity, and of course it is dependent on various factors, and how to place it, that we have to understand. Placing of concrete. Then formwork means shuttering, or you can say molding box, you can say in casting box, created box, constructed box. It's not small box. You can imagine that we are going to lay slab or foundation, raft. How many concrete cubic meter are going to do? So box is very big. It's not small box for casting or for, you can say, foundry. It's a big box. And then how to do curing, which means it's a treatment to concrete if evaporation happens excessively, and how to keep lab water content, which shall be used for purpose of reactions, chemical reactions, for doing chemical reactions, and without chemical reactions strength cannot be achieved. So formwork and curing is also having powerful system, and it depends on how we organize it. Then reinforcement, though it should be in advance, but reinforcement is prime soul of concrete, because concrete is a material that can take compressive forces very well. Concrete is good in compression, we all know, while steel is good in both, in fact, but generally we use steel for purpose of tensile stresses, for purpose of tension resistance only. It may be bending tension or it may be some other tension. That is why we call it steel reinforcement, is much more much more heavier, is much more important than, you can say, all other requirements, because first of all it cannot be seen in concrete. Once you do it, you use this, you cannot see it, and that's where hidden item it is we call. But hidden important item or hidden directing item, lead item, it requires design, excellent design. It doesn't happen because we just want to add steel. Concrete design and reinforcement design are of course very significant parts of designs. And of course not only design but also construction. How do we construct it? Then we can say construction joints is another word. Construction joints are required in construction. And then inspection and testing of hardened concrete. Hardened concrete means it has changed its strength. It's changed its state of liquid. Because when concrete is mixed, it's liquid state, and when we place it, gradually it gets into a state where we can say it's neither solid, not liquid, and later on it solidifies when it's set, and then becomes, after a gap of many days, you feel that when you test it, you will find so much strength it has achieved. And some cases it has used faster. Therefore, hardened concrete is a good statement, we can say, a good title. Hardened concrete we have to test and we have to inspect. That is inspection and testing of hardened concrete. And we have protective coatings to concrete. Many people may not be clear about this, but it's very easy to understand, because concrete, if exposed to weather or exposed to something, it can spoil concrete surface. We have to take care about that, and that's why you can say protective coating to concrete is required. What sort of protection you are going to give? Is it rendering of plastering or something else? That point you have to understand very well, and that point is really wonderful if you understand how to protect concrete from impacts of soil chemicals. Concrete question is raised. It's very hot. We cannot do this concrete in daytime. It's difficult because it's hot, and we don't want to do this. And also this temperature does not suit. This temperature, we have concrete temperature, but we want to temperature say 45 degrees or 50 degrees. How can we say we'll concrete in this temperature? हम नहीं कह सकते, लेकिन करते हैं. कंक्रीट एक ऐसा मटेरियल जिसकी कल्पना तो आप नहीं, अब तो आवश्यक जानते हैं आपकी क्या है ये, हमें सब नहीं जानना. We know what is concrete, what's temperature, how does it relate to concrete, इसका रिश्ता क्या है कंक्रीट से, ये हम जानते हैं और जानना चाहते हैं. और हम नहीं जानते, इसीलिए प्रॉब्लम आती है. घर में नहीं देखते कितने उठाई कंक्रीट कर दी. कंक्रीट करने वाले भी नहीं जानते, कंक्रीट कराने वाले भी नहीं जानते. और जहाँ तक मैं समझता हूँ, हम लोग इंजीनियर भी इसको बहुत कम जानते हैं. पर्टिकुलरली हमारे देश में हम नहीं समझते. मैं बुराई नहीं कर रहा यहाँ किसी की, क्योंकि हम लोग अपनी किताब से बाहर नहीं आना चाहते. दुनिया में क्या क्या चेंजेस हैं हम जानना नहीं चाहते, ना पढ़ना चाहते. इसलिए हमको इंफॉर्मेशन की कमी रह जाती है. और हम इतने बिजी होते हैं अपने काम में कि शायद हमको समय भी नहीं मिल पाता होगा, हम चाहते भी होंगे तो it happens. So relation of weather and concrete are like, existing or non-existing, survival or non-survival, good or bad. Weather is very important factor for concrete, and we have to see that if weather does not suit, it can impact on properties of concrete. It's not simply that I have mixed concrete and placed. Taking care of that is also very important. We have to take care of concrete, whether it's in whatever element we poured, and the purpose of, we call it curing, because we lost something, concrete lost something of sound. And when concrete loses means you lose. How to get it back, how to keep it in a position that's poured, and how many hours required for that. So you may say, then miscellaneous, which meaning of miscellaneous very clear to everyone. What is miscellaneous? Whatever you have missed, you have to collect in that. You may say that. Then precast concrete. We know precast concrete, pre-stressed concrete. Of course, both are different subjects, but we're talking of concrete. How we handle this when you do precasting, how to handle this when you do pre-stressing, and water retaining structures. When you say water retaining, is very different. It's completely different discipline. This domain of water retention. Sections in this, that is general, and of course quality requirements and controls, and of course structures, that's foundations and retaining structures, or road work, which is different world, then drainage work, and add some mechanical and electrical equipment. And then we have some references from American Society of Testing Material, and that is standard practice for curing concrete, making and curing concrete test specimen, and of course method for compressive strength of cylindrical concrete specimen, and then test method for slump of hydraulic cement and temperature of freshly mixed hydraulic cement. All this and civil engineering terms, some terms of glossary buildings. We have to care about that. Then test for general properties of aggregate, methods for sampling, and test for general properties of aggregates, methods for reducing sub-laboratory sample. Then we have method of sampling fresh concrete on site. Then we have testing fresh concrete, and that is lump test. Shape, dimensions, and other requirements, we can say. Shape, dimensions, and the requirements. Of course, we have then making and curing specimens for strength test, and of course we have testing of concrete part 1, that's sampling of fresh concrete. Testing of concrete part 2 is properties of fresh concrete, and testing of concrete part 3, making and curing test specimen. And these are some from European codes, ISO, and some from British likewise. You can see we have like that. And then we have certain definitions of symbols, and these are very common. You know what is this? For example, degree Celsius is degree Celsius degree, then it is CL, that is calorie, cm is centimeter, D is day, and FCK is cylinder, which clearly indicates that compressive strength, that's characteristics compressive strength of concrete determined by testing cylinders, because cylinder is written there. And same way FC, CY, L, compressive strength of concrete determined by testing cylinders. Then FCK which simply says that characteristic compressive strength of concrete determined by testing testing cubes. So we basic characteristic strength means of a cube. And we can say FC cube compressive strength of concrete determined by testing cubes, and of course FCM means compressive strength of concrete, and we can say same way FCM we say before that FCK and C cube, and FC cube, because the FCK cube is characteristic compressive strength of concrete determined by testing cubes, and same way compressive strength of concrete determined by testing cubes. And CM FCM mean compressive strength, FCM means mean compressive strength of concrete, and MC with J, which is there, means compressive strength of concrete at a stage of 1 days. And yes, you can also say here that GGBS, that is granulated blast furnace slag, and GUTS is guaranteed ultimate tensile strength. And then we can say H stands for hour, kg stands for kilogram, kj stands for kilojoules, kn stands for kilonewton, L stands for liter, and m stands for meter, m square stands for square meter, m cube is cubic meter, mg is milligram, min is minute, and mm is millimeter, m square is square millimeter, months is months, and MPa megapascal, and kPa kilopascal, MSRPC means moderate sulfate resisting Portland cement, and OPC is ordinary Portland cement, and PFA is pulverized fly ash, and of course PVC is polyvinyl chloride. Then we have S is equal to second, and we can say SF is equal to silica fumes, SRPC is state sulfate resisting Portland cement, and then we have here in tonnage is 1000 kilogram, everybody knows, and ppm is part per million. Micron is 10 to the power minus 6, and micrometer is 10 to the power minus 6 meter, 10 to the power minus 6 meter. In that case, we go to reference to technical society, institutions, association, or government authority. These are here, we can just say ASHTO. It's only for information. I'm not saying that we have to remember them. ASHTO, that is AASHTO, American Society of State Highways and Transportation Officials. ACI is American Concrete Institution, ACI. ASTM, American Society for Testing Testing and Materials. And they have to test and material by these reports. In that case, they have American Welding Society, AWS, as well as BS, this British Standard. And you have BSCP, British Standard Code of Practice. Likewise, we have so many. We have C&CA, that is Cement and Concrete Association. CIRIA, that's very famous. CRIA Syria, and that is Construction Industry Research and Information Association. Construction Industry Research and Information Association. And then we have Concrete Center for Steel Insight Institute, and that is CRSI, Concrete Research, Concrete Enforcement Steel Unit. Then we can say CS, that's Concrete Society, and of course C, as we have said. Then DIN, Duchess Institute for Normung and V, Of course, we can then DIN, that is Dutchess Institute for Normung. Dutchess Institute for Normung, that is DIN. A norm is US norms rather than normans. EN is Euro norm and FHWA is Federal Highway Authority. GSO, GCC, Standardization Organization. GCC, it's Gulf Central Council, Gulf Council, Gulf Countries Council. GSO is GSCC, Standardization Organization. IC is Institution of Civil Engineers and ISO is International Organization for Standardization. PCI is Priestess Concrete Unit Institutes, and PQCS is Qatar. And of course we have here PCI, Priestess Concrete Institute. QCS is Qatar Construction Specifications that we are referring to. We have QS, Qatar Standards, and UFQDFT is United Kingdom. Products, what's that? Approved products, contract specification, contract specific documentation may identify approved products and approved or pre-qualified manufacturers and suppliers of products used in concrete work. We have the implementation, approved installers, contract specific documentation may identify approved or pre-qualified providers of concrete construction services. It's an important point. Then contract specific documentation may identify approved or pre-qualified providers of concrete construction services. Field quality control, field quality control, sometimes field quality control, contractors shall carry out test procedures required by this section and whatever other tests and test procedures as directed by engineer from time to time. Test procedures shall be carried out using facilities of an approved independent testing laboratory. So you can say contractors shall carry out test procedures required by this section and whatever other tests and test procedures as directed by engineer from time to time. It's a problem, I think. Test procedures shall be carried out using facilities of an approved independent testing laboratory. Supply, storage, sampling and testing. Supply, storage, sampling and testing of all materials. It's the responsibility of contractor unless contract specifies otherwise. Engineer can also require contractor to take samples of materials and deliver them to Central Materials Laboratory for additional tests to be carried out by employer of sampling procedures. and it shall be in accordance with BSCN 932 or relevant STM standards, and sample sizes shall conform to requirement of shown table 1.1. And this is sample sizes shall conform to requirement. And what is requirements? Let's say it is material, and here is sampling procedure. It's material and then test, and then of course minimum sample. So first material is cement, then aggregate, then reinforcement, then water. So we can say cement test is full range of tests. And in this sample is 7 kilogram, and it should be taken from 12 bags. Says that 7 kilogram sample can be taken from 12 bags for full range tests. And then for aggregate, which is also maybe 8. We have aggregate, both aggregates, and for this we know samples of 200 kilogram. For what, out of this 200 kilogram, we have to conduct sieve analysis, chemical analysis, soundness test, and water absorption. Then in that case, we can say sieve analysis, very important test, and chemical analysis, soundness and test, and we can say water absorption, plastic particle density, flakiness index, fines contents, Los Angeles aberration value. These are very important tasks. You can raise sieve analysis, chemical analysis, soundness test, water absorption test, particle index density, flakiness index, and fines content, and Los Angeles aberration value. In first case, when you want to range full thickness test, 200 kilogram cement, and in this case 50. Now 50 kilogram of aggregate, we have to take sample has 200 kilogram cement reinforcement test, and reinforcement in tensile test and bend test. In tensile test, this is 500 mm. So in bend test, this is 300 mm. For sure, and then we have reinforcement, that is tensile test and bend test, and tensile test is 500 mm you need, and of course bend test you need 300 mm. So water is full range of test, and that's 5 liter. Equipment, minimum equipment required for testing on site is table given. Given that table, and Here we have sampling procedure that is in accordance with, you can say, engineer may also require contractor to take samples of materials and deliver them to central laboratory for additional tests to be carried out by employer. Sampling procedure shall be in accordance with this EBSCN 932 or relevant ASTM standards, and samples sizes shall conform to requirements in table 1. Size means how many we need here, that we are seeing then. Then it is minimum equipment. Minimum equipment required for testing on site is given in table 1 2. Let us see what is that. This is table 1 2, and it's also very important in this we can say test and equipment and minimum number required. The slump test, which we say slump cone with base plate, we need slump cone. We require compacting rod, circular one, and round ends. Then remixing container, it can remixing itself. After that we can say slump test we have taken care of. Slump cone with base plate, compacting rod, circular cross section and round ends. Remixing container, 300 mm ruler, moist cloth, and scoop and shovel. We have then curing, as we said, Asian or sacking, impervious sheet, maximum minimum thermometer, waterproof making, crayon paint or equivalent, curing tank in air conditioned room, supply of placing, so replacing. Of course, we have concrete thermometer also, curing tank in air conditioned room, and supply of packing material. And then we have the curing tank, supply of packing material for sending cubes and cubes to commercial laboratory, concrete thermometer. Then we have to go to now concrete, and that is what is actually we to do, what is general, what is scope, references, definitions, source approval, sampling, quality and testing, storage at contractor place, plant, fine aggregate for concrete and mortar, coarse aggregate for concrete, combined aggregate for concrete, washing and processing, lightweight concrete, coarse cycle. Size. This part covers requirement of aggregates for use in structural concrete. And what are these? We can say cementitious materials, water, property requirements, concrete plants, transportation planning, concrete, transmission planning of concrete, hot weather conditions, hot weather concreting, and also soft well, So we can say for we have standard methods, standard specifics of concrete aggregate, and test method for organic impurities in fine aggregate for concrete, that is for detection of organic impurities in fine aggregates. Then soundness of aggregates by use of sodium sulfate or magnesium sulfate, that is test for soundness of aggregates where we use sodium sulfate or magnesium sulfate. Then test method for lightweight pieces in aggregate, lightweight pieces. And then test method for specific gravity and absorption of coarse aggregate. And then we have here, you can say specific gravity. Then we can say test method for sieve analysis, or you can say resistance to gradation of small size coarse aggregate by absorption, abrasion and impact of Los Angeles. That's very important. Resistance to degradation of small size coarse aggregate by abrasion and impact in Los Angeles machine. And standard test method for sieve analysis of fine and coarse aggregate. Test method for clay lumps. Uh, We can say then, of course, when we are talking of tests, we talked of Los Angeles, then we have to sieve analysis of fine and coarse aggregate and clay lumps and friable particle aggregate. Then we have method of resistance to degradation and of large size coarse aggregate by aberration and impact in Los Angeles machine. Then standard practice for reducing samples of aggregate to testing size, and then of course standard practice for sampling aggregate. Then we have certain digest, PRE digest, that is alkali silica reaction in concrete. alkali silica reaction in concrete, detailed guidance for new construction, and we have then tests for geometrical properties of aggregate, that is determination of particle size or flakiness index, and tests for geometrical properties of aggregates, the determination of shell content, potential content, percentage of skills or shell or cross countries. And of course we can say then after this geometrical properties, then we have tests for geometrical properties of aggregates, and that is determination of shell content, percentage of shells in coarse and we have then geometrical properties of aggregate, determination of shell content, percentage of shell in coarse aggregate, as well as then properties of aggregate, assessment of aggregates, classification test for constituents of coarse cycle aggregate, I think others. Then we have to say that tests of geometrical properties of concrete aggregate classification test, constituents of coarse recycled aggregate, then mechanical and physical properties of aggregate, determination of particle density and water absorption. Then we have complementary standards, specifications for continuous constituent materials and concrete. There is of that, we can say that mechanical and physical properties of aggregate, determination of particle density and water absorption, complementary building standards, specifications of constituent materials and concrete and aggregates for concrete, and chemical properties of aggregate, chemical analysis, chemical properties of aggregates, determination of acid soluble chlorides, salts, and then tests for thermal and weathering properties. और ये में we have then built standards and specific constituent materials and concrete aggregates for concrete, and chemical properties of aggregate, chemical properties of aggregate, determination of acid soluble chlorides, and thermal and weathering properties of aggregate, magnesium sulfate test, definition of drying shrinkage, aggregate, geometrical properties of aggregate, and we have then tests for mechanical and physical properties of aggregate, methods for determination of resistance to fragmentation, and we have test for mechanical and physical properties of aggregate, determination of particle density and water absorption. We have lightweight aggregate for concrete, mortar and grout. We have aggregates for concrete, and guidance to use BSEN 12620. Then we aggregates lightweight aggregate for concrete, mortar and grout, and then guidance to use of BSEN 130551. Mortar and specification for mortar for masonry mortar. Then we have quality system, that is management system requirements, IS 9001-2008, now it's 2015, and ISO 17025, that is required for competitions of testing and calibration laboratories. RILEM, RILEM R1, that is recommended test method R1, detection of potential alkali reactivity aggregates, petrographic method. Then we have RILEM recommended test methods R3, detection of potential alkali reactivity, 38 degrees test, method for aggregate combination using concrete prisms. In definitions we have what is aggregate. What is aggregate? That's a very interesting one. Granular material used in construction and may be natural, manufactured or recycled. Granular material used in construction, which may be natural, manufactured or recycled. Natural aggregate defines how it is defined. Natural aggregate defines itself. Aggregate from mineral sources, which has been subject to nothing more than aggregate of mineral origin, resulting from an industrial process involving thermal or other modifications, that is manufactured aggregate. Recycled aggregate resulting from processing of inorganic material previously used in construction. Then lightweight aggregate of mineral origin having a particle density not exceeding 2000 kg per cubic meter or a loose bulk density not exceeding 1200 kg per meter cube. Recycled aggregate and lightweight aggregate. So we have here sources of source approval. Source approval. Source means you know what is source, from where we get that aggregate. You can say shall use only those imported material sources from accredited qualified quarry, registered quarry, you can say, accreditation we call it. Contractor shall use only those imported materials sourced from an accredited quarry, producer or accredited supplier which have been approved by national standards on their representative. So you can say this is a quality approach. Accredited aggregate supplier shall provide source name for every shipment and aggregates significantly different. in terms of physical and chemical properties, thus ensuring that resultant concrete continues to comply fully with specified requirements. Producers are suitable to be accredited. Preference will be given to organizations with a proper quality management system, such as ISO 9001 or another in the one. Of course, we can say that when we can say here, it says when considering whether an aggregate supplier or aggregate producer are suitable to be accredited, preference will be given to organizations with a proper quality management system, such as ISO 9001 or another quality management systems approved by standards. When requested by engineers, aggregate supplier shall provide a geotechnical analysis on rock samples before blasting and grinding to ensure proper quality of material. Means supplier from whom you get aggregate has to provide geotechnical analysis on rock samples before blasting and grinding to ensure proper quality of material. Aggregate shall be properly stocked and labeled without intermingling at any storage area. When requested by engineer, aggregate supplier shall provide data for past 6 months consistency of materials and conformity with specification, and suppliers shall verify compliance of aggregates according to specifications by an independent qualified testing agency accredited to ISO 17025, that is compliance of aggregates 17 ISO 17025, and approved by standards, and sampling, then you can say sampling. Sampling, contractors to engineer in accordance with requirements of relevant standards in QCS. It's QCS to engineer in accordance with requirements of relevant standards for sampling. Sample reducing and testing of aggregate. Sample reducing and testing of aggregate for testing at least 2 weeks before beginning deliveries to site. So it is sampling, we are talking of how to sample. So first is provide samples for both aggregate, that is coarse and fine, to engineer. in accordance with standards requirements for sampling and sample reducing and testing of aggregate for testing at least 2 weeks before beginning deliveries to site. And these samples shall be taken in presence of engineer or an approved testing agency assigned by engineer. Aggregate sampling and testing shall be sampling. Now quality we are talking of, quality and testing. So aggregates shall consist of tough, hard, durable and uncoated particles. Aggregate shall consist of tough, hard, durable and uncoated particles containing no harmful material in quantities sufficient to adversely affect concrete or reinforcing steel and contain no materials likely to cause staining or otherwise disfigure concrete surface. Aggregate shall contain no materials other than most of them is likely to cause staining or otherwise disfigure concrete surface. Aggregate shall be obtained from a source approved by engineers. Aggregate shall meet requirement as given in table 2.1 as we said before. Additional tests detailed in BSEN 1260 with BSP 6622 published document 6682 and EN etc. or relevant standards and codes of practice may be required by engineer to satisfy certain requirements. Contractor shall provide in accordance with requirements of BSEN, all these, and then fine aggregate. We have fine aggregates shall be natural sand or manufactured crust rock, natural sand or manufactured crust rock sand, and you can say crust rock sand shall be direct produced of a manufacturing process, not byproduct of coarse aggregate production. Beach sand shall not be permitted for use in concrete mixes. Use of clean dune sand blended with coarser sand may be permitted. Then we can say here, right, then routine testing shall meet requirements as listed in section 2. Frequency of testing may be increased by engineer's request if testing results show inconsistency, and frequency may be reduced if so the frequency of routine testing shall meet requirements of listed in section 2. Frequency of testing may be increased by engineer's request if testing results show inconsistency, and frequency may be reduced if approved by the engineer if metals are highly inconsistent. Mineralogical tests are to be carried shall be made to site until engineer has approved samples as complying with specification. I can say storage at contractor plant. Aggregate shall be stored as follows. Each nominal size of coarse aggregate and fine aggregate shall be kept separated and clearly labeled at all times. Height of stockpiles shall be controlled to prevent harmful segregation and breakage of aggregate. Stockpile shall be on hard and clean surfaces. Hard and clean surfaces, you can say, with not more than 5% slope. So this is stockpiles, 5% slope. 5% means 5 in 100, that is 1 in 20. Stockpiles shall be on hard and clean surface with not more than slope. Yes, sir. By ground or other foreign matter shall be effectively prevented all times. Each heap of aggregate shall be capable of draining freely. Stockpiles shall be protected from direct sunlight. Unloading of aggregate shall be controlled to prevent harmful segregation and breakage. Contractor shall maintain stockpiles of concrete coarse aggregate in separate grading. Contractor shall maintain stockpiles of coarse aggregate in separate gradings, and a construction site, preparation, location, and of any mechanical. What is aggregate and normal concrete? I will be back in a couple of minutes. Meanwhile, you can just have a word on this. Couple of minutes for me, and I'll come back. So I think, well, sorry gentlemen, the delay. There was some issue. So about every site should be separately stocked. Height of stock should be controlled to prevent harmful segregation and breakage of aggregate. Stockpile should not be more than 5% slope, and contamination of aggregate by ground or other foreign matter shall be effectively prevented at all times. Each heap of aggregate shall be capable of draining freely. Stockpile shall be protected from direct sunlight. Unloading of aggregate shall be controlled to prevent harmful segregation and breakage. Unloading of aggregate shall be controlled to prevent harmful segregation and breakage. Contractor shall maintain stockpiles in coarse aggregate in separate gradings. At construction site, preparation, location, and size of whatever stockpile shall be approved by engineer. Now there is a table to 1. It gives limits of physical, chemical, and mechanical properties of aggregates for normal concrete. Physical, chemical, and mechanical properties of aggregates for normal concrete. This table is number, serial number, requirement, test methods which are BSEN or STM, and permissive limits for fines and coarse. It's here, and we can start. Grading is one. Here requirement is grading, then natural, materials, fine. Then there is clay lumps and friable particles, lightweight pieces, organic impurities for fine aggregate, water absorption, then particle density for normal weight, shell content, flakiness index, acid soluble chlorides, reinforcement in mass concrete, and pre-stressed concrete, steam cured. Magnesium sulfate, a resistance to fragmentation, that is Los Angeles aberration, drying shrinkage, potential reactivity. In this grading is number 1 here. BS is 9331. Its fines, its permissible limits, fines standard and coarse standard. And we have natural materials fine and 0.063 mm. BS 9331. In this, permissible limits for fine is 3% maximum, that is fines, and 2% maximum for coarse. So it is that one. this you can say fines quality. Structural concretes and equivalent percentages. 60% in fines and non-structural concrete, that is methylene blue adsorption value, that is cube, is 1 gram per kilogram. That's maximum. So we can say clay lumps and friable particles. Clay lumps and friable particles. ASTM 6C142. Permission limit is 2% maximum clay lumps, friable particles, and coarse is 2% maximum. That is 0.5% maximum in fine and 0.5%. C40 it is. Organic impurities for fine aggregates. Color standard not darker than plate number 3 to power 4. 3 to 4. Plate number, maybe there's a reference, we'll check. Color stand not darker than this one. And in coarse it's not applicable. Means this says that organic impurities give color to material. Water absorption, saturated surface, dry, that is 1097.6. Water absorption is 2.3% maximum in fine and 2% maximum in coarse. Particle density for normal weight concrete. Particle density for normal weight concrete 1097.6. 2 minimum. Shell content 33.7. In fine it is 3% maximum and 933.3. In coarse it is 35% maximum. Yeah, when I worked there in Qatar it was 25%, I think 15% one time. In 1986 it was 15%, but it was a great impossibility, so they increased to 25%, and now it's given 35%, so it's quite good. So I think this is comfortable because of many other replacements. Acid soluble chloride 1744.5, in which case reinforced and mass concrete or massive concrete, fines 0.06% maximum, acid soluble chlorides and for coarse 0.03% maximum. Pre-stressed concrete and steam cured structural concrete 0.01%, that is acid soluble chlorides for fines and surface sulfate, acid soluble sulfate. Test method is BS 1744-1. Fines are 0.4% maximum acid soluble sulfates and coarse is 0.3% maximum. Soundness by magnesium sulfate 5 cycles 1367-2. Permissible limits 15% maximum in both cases. Soundness by magnesium sulfate. Then resistance to fragmentation, loss injury separation 1097-2. 30% maximum case of coarse, that is resistance to fragmentation, 30% maximum. And drying shrinkage 13.674, 0.075% maximum for course. No need of fines and potential reactivity. BSEN or relevant standard, that is GSO, Gulf Standard Organization standards. If sand equivalent value is less than 60%, if sand equivalent value is less than 60% and greater than or equal to 50%, sand shall be considered non-harmful. If sand equivalent value is less than 60% and greater than 50%, this means it lies between 50 and 60%. Sand shall be methylene value values less than or equal to 1 gram per kilogram. Not required when fines content in fine aggregate or in all in aggregate is 3% or less. Not required when fines content in fine aggregate or in all in aggregate is 3% or less. In organic impurities, use of a fine aggregate filling in test is not prohibited. Use of fine aggregate for filling in test is not prohibited, provided that discoloration is due principally to presence of small quantities of coal, lignite or similar discrete particles. Discoloration is due primarily or principally to presence of small quantities of coal, lignite or similar discrete particles. When tested for effect of organic impurities on strength of mortar, relative strength at 7 days calculated in accordance with the STM-C87 is not less than 95%. Tested for effect of organic impurities on strength of mortar, relative strength at 7 days calculated in accordance with the STM-C87 is not less than 95%. If chloride content is higher than 0.01%, if aggregate content is higher than 0.01%, following steps may be taken, and that is aggregates may be washed by suitable water before mixing to lower chloride content to specified value 0.01. If washing process does not reduce chloride content, required value acid soluble chloride content in concrete ingredients, acid soluble chloride content in concrete ingredients shall be tested as mentioned in BS 85002. Allowable acid soluble chloride content limit shall not exceed value given in section 5, part 6, para 653. Alkali aggregate reactivity shall be assessed at source in accordance with BS 2061, BS 85002. Certification shall be obtained from aggregate source indicating absence of deleterious expansion of concrete due to alkali aggregate reactivity. So this is another fine aggregate for concrete and more. So we'll see that now. What we got, this is all here. Concrete mortar. Fine aggregate consists of natural clean sand, stone screenings or a combination, and can be produced from natural disintegration of rock or gravel or by crushing of rock or gravel or processing of manufactured aggregate or artificial conforming to requirements of physical and chemical properties, complying with Table 2.1 and subject to engineer's acceptance. Crushed fine aggregates may be blended with local washed sand, provided that final aggregate complies with requirement Table 2.1. We'll see what's Table 2.1. Gradation of fine aggregate for concrete and mortar shall be in accordance with gradation designation BSEN 12620 with BSPD 6682 EN 13131 EN 9981 EN 9982 of relevant ACI and ASTM standards and codes. Each batch of aggregate, will be kept separate from previous batches and stored allow be mechanically washed to remove salts and other impurities in order to meet specified requirements. Storage area for clean washed sand shall be shaded from direct rays of sun and screened for protection from dust. Screened for protection from dust. Area in neighborhood of stockpile mixing plant shall be watered as necessary to reduce rising of dust. Uses of dune sand shall be accepted as governed by regulation of state, environment and shall be not used for any reinforced concrete, used only for blocks, block mortar, plasters, soil cement, shotcrete and insulation. Let's see, while fine aggregate consists of natural clean sand and stone screenings, you can say stone screening or a combination and can be produced from natural disintegration of rock or gravel and by crushing of rock or gravel or processing of manufactured aggregate or artificial conforming to requirements of physical and chemical properties. Well, this will take up because we have to go very slow in this. As quality we are talking of, we have to understand everything clearly. Only then we can say what is quality. We cannot rush up leaving everything behind, and it's therefore very is heart of engineering work, or you may say most of site works, most of concrete, then we have to go through combined aggregate for concrete, washing and processing lightweight aggregates, coarse recycled aggregates, and then we have to see table 2.2. This is here. Table 2.1 was there, I think. 2.1 is saying 2.1. Where's that? I think this is 2.1. Is it? Let me see. Yes, it is 2.1. We are talking there. In which we have gone through limits of physics. aggregate and coarse recycled aggregate. We have to see what is that. Of course, then requirements for coarse recycled aggregates and coarse RA mass fractions. And then it is, can say, end of this part. Then it starts concrete, cementitious materials after this, which is also interesting one, because cementitious materials, PFA, etc. we have to run very fast on this. It's very complicated and very good, knowledgeable subject specification. I want to share this with you because this is well done, deeply worked by these people. We have to understand facts. We are going to do quality work. We have to understand contracts, and we have to understand specifications. And of course, then contract specifications. They have to upgrade knowledge, and also designers, this topic, this specification, systems that quality has. Every designer is required to know it. It is not only in interest of designer, but also in interest of designs. Site executives, this part of design, we have to think on this, we have to rate such, and we have to refer it when we check trial mixes or we check proposed vendors such as concrete suppliers, or we take into consideration, you can say it's a work between basic design to construction work, or you can say basic design to design and somewhere in construction work. We can't expect construction workers to go to construction engineers to go to details of these tables. We can't. Yes, maybe I have to repeat few minutes later on in next video. Frames are available, but audio and video here, system is blamable. But when we do work other than our country, systems work. Maybe 100% this system doesn't work, but to some extent it works. Unfortunately, people don't have access, they don't have interest to know about minute minute specification arrangements, provisions, like these tables we are talking of, like these materials we are talking of, we are discussing. Likewise, temperature controls. Controls means all come under preview of quality control. And quality control means quality plus system. And system itself has a quality. So we just think that we'll test it and it's okay. That would not be enough. We have to be very strong, innovative. There's no way out. It must be brought to that level. Quality is soul of material, soul of product. And when we refer to civil construction product, these are very expensive, voluminous, and these have to work or serve for many decades to come. And that is difference between construction products and other products. Construction product always heavy, cost wise, time wise, activity wise, or whatever other factor involved, that wise. Other engineering branches do not weigh heavy because no machine can work for 50 years and no part can भी कुछ समझ आएगा। और अगर हम दूसरों से ही पूछते रहेंगे तो कुछ समझ नहीं आएगा। इसलिए मेरा रहता है ध्यान कि मैं जितने ज़्यादा से ज़्यादा इन्फॉर्मेशन आप लोगों से शेयर कर सकूं, अच्छा है। ठीक है, आप लोगों को बुरा लगता होगा या आप लोग बोर होते होंगे, कौन इतना लंबा वीडियो देखे। ठीक है, आपके पास समय नहीं है, लेकिन ये कोई फिल्म भी नहीं है। मैं कोई फिल्म तो नहीं दिखा रहा आपको। मैं तो अगर यहाँ कुछ बात कर रहा हूँ, शायद वो आपको काम आएगी, तो सुनने में क्या जाता है। We have to collect or gather information, and we have to use it after we understand it. Because we spend money, we spend time. If we don't achieve quality, it's a curse on ourselves. I think we don't have any deficiency in our country. except that we are not quality deliverers. We are not quality suppliers. That is our main drawback in whole system of country. It may be technical work or it may be other work. Quality is taken for granted and nobody bothers. Even purchaser, or you can say buyer or seller, both. Nobody is so serious, nobody bothers. They know market is big. Why should we unnecessarily worry? But fact remains that bad quality or substandard material never run too long. They don't have life. This point also we have to understand. They don't have life and you cannot continue with those materials forever. First time, second time, you may cheat someone in this list. They cheat, cheat. And it's very, very difficult. We have to be proactive. Again, I say, we have to be clear in mind. We have to be clear in conscience. And in fact, by soul we should be engineer, not by body. And we should not think all time that my degree works for me. Again, I say degree is honorable. But degree is not alone. It is only a piece of paper which tells us or someone that this person has done it. But your project delivery, how many projects you have done, how many are quality projects, how many are durable, your real degree is that. And that's why when some project is written on CV, it's much stronger because you did it. According to engineering requirements and not to just contractors' requirements. What contractor wants, I'm not concerned. What contract wants, I'm concerned. Contractor is a person, and that person is not my reference, even if I am contractor's employee. Even if I am contractor's employee, my job is not to please contractors, but to please my my being qualified engineer does not make any sense. That point we have to understand very well. अगर हम ये नहीं समझेंगे तो कुछ नहीं समझेंगे. क्वालिटी खेल नहीं है बच्चों का, एक स्मार्ट वर्क भी नहीं है, हार्ड वर्क है, फॉलो अप है, जिद है ये कि क्वालिटी लेंगे. जब तक आप में वो born in 51084, for them quality is a question mark. That point we have to understand very clearly. It's time now to go. I don't want to waste more time. Purpose was disputes occur. With this I can say we must close this and see how can we order, how can we do it. I think I have to, oh, 1 minute please. Thank you very much.